Hello. So today we are going to start engineering mechanics, and this is the first lecture of engineering mechanics. Okay. So a little bit introduction about engineering mechanics. What is engineering mechanics all about? So first of all, introduction. So see, there can be three states. One is solid, the next one is fluid, and next one is gas. So out of these three, engineering mechanics deals with only solid state, but that is not solid state. That is only rigid bodies. Okay. So see, solid, liquid, and gas. This solid can be divided into two parts. First one is rigid bodies, and second one is your deformable bodies. So solid can be divided into rigid body and deformable body. So this engineering mechanics deals with only rigid bodies, not deformable bodies. And this liquid and gas will study under fluid mechanics. So first one is, here is your engineering mechanics. Okay, here is your strength of the materials. So there is a subject, strength of the materials, where we study about deformable bodies. In engineering mechanics, we only learn about rigid bodies. Liquid and gas we will study under fluid mechanics. So this is fluid mechanics. So these are the three subjects. So what is first of all we need to understand what is a rigid body. Rigid body is something, if you apply some force, there will be no deformation, but there may be some change of the position of the body, but there will be no deformation. Deformable body is, there will be no change in the position of the body, but there can be some deformation. So first of all, understood with the example. See, this is a body. Here I am applying some force. Now this body is changing its position but not deforming. Without any deformation, without any change in shape and size, it is moving. So now it is at this portion. If it is at this portion without change in any shape and size, then this is under engineering mechanics, that is rigid body. And if the body is in here, applying some force, it is changing its shape. It is changing its shape but not changing its position. Then it is a deformable body. Okay. So this comes under dynamics. And this is a static condition. This is a static condition, this is a dynamic condition. So dynamic is something where the body is changing its position but not its shape. And for static there are two conditions. First, the load, suppose this is 500 kg. This is 500 kg. The body is changing, it's not changing its position, and the load is constant, it is not changing. Then it comes under static condition, and this body is a deformable body, not a static body. This is a deformable body. Okay. So this is rigid and this is deformable. Okay. So I think you understood about what engineering mechanics is all about. It is about rigid bodies. So next, let us come to a little bit about fluid. So what is fluid? Fluid is something in which if you apply little to little shear force, it will continuously deform. Okay, so suppose this is a fluid particle. If this is a fluid particle, if you apply a little bit of shear force, what is shear force? That you have studied in your strength of materials, but we will see it afterwards. Right now only think shear force is something like this. Okay, so we are applying a little shear force and this body is continuously deforming. That means continuously it is changing its shape. Then again this shear force is here, it is continuously changing its shape. Then it is a fluid particle. So this is fluid particle where the body continuously deforms under a little shear force. What is solid? Solid will deform if a deformable body is that. So that deformable body will deform only after elastic limit. Elastic limit is what? That again we will see in our strength of materials. So suppose there is a limit after which if you apply some force, then there will be some strain which is not removable, not recoverable. It means it is permanent. If there is some permanent strain, then it is after beyond the elastic limit. Till elastic limit, the body has changed its shape, but it will again come to its original position. That is up to elastic limit. Okay, you might have seen the curve of stressed and curve of mild steel. In that you have seen what is the elastic limit, proportionality limit. We will again see, but not in here. So that is why I am not discussing that much about it. So after elastic limit, it will change its shape and size. That is deformable body, and rigid body will not change. Okay. So next one, I am giving you an example. Suppose there is a body. This is a section. Suppose this is section A and this is the section B. This is section A, section B. Now I am applying some force P and P. Okay. Now initially the distance between A and B was suppose 10 centimeter. Okay. After this force, we have applied this force like this. After application of this force, there is some change in this distance between A and B. Suppose then it is 12 centimeter. If this happens, then this body is deformable body. Or if this doesn't happen, then it is a rigid body. Okay. So I think you have understood about rigid body and deformable body, and this was about introduction to engineering mechanics. We will deal with only rigid body. So there are some laws in engineering mechanics. There are some laws. So the first law is going to be law of transmissibility. So this is going to be first one is in law of mechanics. That is, we are going to discuss about Newton's law. So the Newton's first law, what it says, that every body continues in state of motion or rest until or unless there is some external force. It means a body which is at a state of rest or in state of motion will continue to stay in state of rest or motion until and unless there is application of some external force. The second one is going to be the net force acting. In Newton's second law, the net force acting in a body is equal to the mass of the body, the product of mass of the body and the acceleration of the body in the direction of the force. So Newton's first law, it is going to be every body will which is in rest, in the state of rest or motion, will continue to stay in the state of rest or motion until or unless there is some external force on the body. And the second law, the net force acting. Now here there is a thing to understand. The force F is equal to the product of the mass of the body and the acceleration of the body in the direction of the force. That is mass of the body multiplied the acceleration in the direction of force. So what we can write is F is equal to m into a. Okay. Now we know what is acceleration. Acceleration is change of velocity with respect to time. Change of velocity with respect to time, how we can write it? We can write it like m multiplied by dv by dt. This is change of velocity with respect to time. This is constant. Okay. How we can write it? See, this is dmv by dt. See, this mass is constant, but together with multiplying with the velocity, we can get this mv, which is something which is varying. Okay, and this mv is actually momentum. So this is momentum. If this is momentum, then this is telling you about change of momentum with respect to time. Okay. So this is all about Newton's second law, and the third law is very famous. You know, every action has an equal and opposite reaction. So Newton's third law. It is every action has an equal and opposite reaction. So these are the three laws. You know these things, so I'm not writing all this because it will take more and more time. Okay, so this is a little bit about, because we need to understand these things in engineering mechanics. So that is why a little bit about Newton's law, for you to recall everything. The next thing, what we are going to do with some definition of forces, like, you know, okay. See, if there is a body, suppose this is the body, okay, and there are two forces acting on the body, like this. And this is the xy plane also. Okay, so these two forces are acting on the same plane. Okay, if this happens, then we can say this system to be a coplanar, C-O-P-L-A-N-A-R, coplanar system of forces. Okay, second one is, if there is a body and there are two forces acting on the body, like this. See, this dotted line is called line of action of the force. See, this is F1 force, this is F2 force, okay, and the line of action of the second force are in here. So at this point it is meeting at point O. The line of action of the two forces are meeting. So we can say these forces as concurrent. It also possible for three forces, four forces. See, this is the body. One force acting like this, another force acting like this. This is the line of action. This is the line of action. And suppose this force is acting like this. This is the line of action. This force is acting like this. This is the line of action. F1, F2, F3, F4, all of the forces are acting and the line of action is meeting at this point, then we can say these forces are concurrent. If this is not meeting, then non-concurrent. Okay. So this is coplanar, then concurrent. Coplanar is acting on the same plane, and concurrent is their line of actions are meeting at a single point. Then this is a body. One force is acting like that. One force is acting like this. This is force F1. Another force is acting like this. This is force F2. Okay. If these forces are acting like this and the direction of them is same, and F1's line of action was this one, F2 is acting on the same line of action as F1, then we can say this force has to be collinear. This is C-O-L-I-N-E-A-R, collinear. So coplanar, concurrent, collinear. Okay. The line of action of the forces are in a single straight line. The line of action of the two forces are in a single straight line. Then only it is collinear, or else this is non-collinear. See, this is the body. One force is acting like this, another force is acting like this. This is F1, this is F2, and this is non-collinear. Okay. Now we are going to study about law of transmissibility of forces. So this is law of what it states, law of transmissibility. It means if there is a body and in that body some force is acting, then due to that force the body is having some acceleration and it is moving. Okay, this same thing can be done with some other force. It means this force F1 can be replaced by some other force, say F2, if the direction and the magnitude of the force 2 is same, and also the force F2 is acting on the same line of action of the force 1. What I'm trying to tell, just understand. Suppose this is one body, okay, and we're applying some force F1 in here. This is the line of action of this force X1, and this F1 is having some magnitude and its direction is like this. Okay, this F1 can be replaced by another force, say F2, which is having same magnitude and direction, and it is also acting in the line of action of F1. See, this is force F2. Okay, F1 is equal to F2. F1 and F2 have same magnitude and the direction of them are also same. Okay, the direction, it is acting with some theta angle with the horizontal. This is also acting at an angle of theta with the horizontal. The direction of these two forces are same, magnitude is same. Then this F1 can be replaced by F2. That means F2 will produce the same amount of acceleration on that body if it is replaced, if F1 is replaced by F2. Okay. That means there are three conditions. First one, F1 will have to be is equal to F2, magnitude is same. Second condition is the direction of F1 and F2 has got to be same. And third one is the line of action of F2 will have to be on the line of action of F1. But the line of action of both the forces should be in a straight line, in a same straight line. Okay. Then only this law is studied, the law of transmissibility of forces. Next one is composition of forces. See, from composition of forces, what we are going to see is, suppose there is a body and there are 2, 3, 4 forces acting on it. Due to this application of so many forces, it is having some magnitude, it is having some acceleration, the body is having some acceleration. Then all these forces can be replaced by one single force. Okay, and that if this is possible, then that one single force will be their resultant. It means that one single force can replace all the other forces. Then if it is possible, then that one single force will be called its resultant of all the other forces. See, force 1 was acting like this, F1, F2 was acting like this, and F3 was acting like this. Okay, all these three forces are acting like this and that. Okay. Due to this, that body was having some acceleration in this direction, the body was having some acceleration in this direction. Now one single force came, and one single force like this. If this one single force can replace this F1, F2, F3, it means due to that one single force, if the same magnitude of acceleration is occurring on that body, then we can say that one single force has replaced all the other forces, F1, F2, F3. Then this is that one single force will be called their resultant. So this is R, the resultant. Okay. The next one is, we are going to talk about some laws of mechanics. That is, say if there is a concurrent and coplanar, it means same plane and concurrent. The forces are concurrent, okay, not non-concurrent. If this happens, then to find their resultant, there are so many ways. Okay, what we need to do is finding the resultant. Resultant is more important. So we are going to see how to find the resultant. What I have talked about, resultant is one force which can replace all the other forces. So to find their resultant for a two-force system, when there is two force only, okay, F1 and F2, to find the resultant F1 and F2, we want this F1 and F2 to be replaced by one single force, their resultant. Then how we can find their resultant? It means in what is the magnitude of their resultant and what is the angle at which their resultant is acting. So see, there are two ways to find this. One is parallelogram law of forces and this one, second one is triangular law of forces. So first one is parallelogram law of forces, and the second one is triangular law of forces. Parallelogram law of forces and triangular law of forces. Okay, this is how we find the resultant of a two-force system, not more than two. So this is only applicable when there are two forces. And the forces are coplanar. And the forces are concurrent. It means their line of action are meeting at one single point. Concurrent. So let us see how it is done. Okay. The first one, parallelogram law of forces. Suppose one force there is a force P and there is a force Q. Okay. Before that, suppose there is a body. Okay, a body like this. At this body, one force is acting like this. Another force is acting like, you can say, this. Okay, this force P, there is an angle between these two forces. This is theta. Okay, this is P, this is okay, this is Q. Okay, so the force P is actually of 100 Newton and force Q is actually of 60 Newton. Take for an example, this is 100 Newton and Q is 60 Newton. Okay, now what we are going to do is replace, we are going to see this magnitude as a length. Okay, we are going to just assume we are going to convert this magnitude with length. Okay, this is 100 say 20 say, or assume 20 Newton is equal to 1 centimeter. Then 100 Newton force P, 100 Newton is equal to 5 centimeter. Force Q, 60 Newton is equal to 3 centimeter. Okay. Now what we can do is with this 5 and this 3, we can draw the forces, the force system. I think you have seen this. Okay, so I'm cleaning it. So what it was, force P was 5 centimeter, force Q was 3 centimeter, and the angle between these two forces was theta. So I am drawing the same. This is force P 5 centimeter and force Q, that is 3 centimeter. Okay, this length is 3 centimeter, this length is 5 centimeter. Okay, now how their resultant will be? In parallelogram law, what we do, we just draw a parallel line of this from here. See, the length of this line is also 5 centimeter. Okay, and the length of this line is also 3 centimeter. Okay, so this is Q, this is P. If this happens, then their resultant will be this. Then their resultant, this is the resultant, the R. Then after that, we need to find the value, the magnitude of the resultant. See, we know that the angle between these two forces are theta. This is the angle theta, and take this angle between force P and their resultant as as alpha. This is the alpha degree angle. Okay, so if there is a force F which is having an angle theta with the horizontal, then we can say this force will have two components that we know. And if you don't know that, then I'm telling you, this force will have two components. One is like this, another like this. Okay, so this force is F, which is having a angle of theta with the horizon, with this plane. Then this is going to be your F sine theta, and this is going to be your F cos theta. Okay, so this is going to be your F cos theta, F sine theta. We are taking the parts of this to component of this force F in horizontal and vertical direction. So similarly, what we can do in this case of Q, we can write this as if this is Q, see, understand very carefully, if this is Q, this is also Q, this is also same thing. Okay, so for an example, we can take this length and this length is same. So what we are going to do is we are going to draw a triangle in here. Okay, suppose this line, this is the vertical component of Q, and this is the horizontal component of Q. Then this is going to be your Q cos theta, and this is going to be your Q sin theta, just like this one. Okay, so if this part is Q cos theta, if this part is Q cos theta, then this part is also that Q cos theta, and this part is also Q sin theta. Now we can understand that there is a right angle triangle. Right angle triangle is where? Here. Okay, so this is your base, and this is your hypotenuse. So now what we can do is, this is the angle alpha, this is your height, this is your base, and this is your hypotenuse. So what we know, that is your this hypotenuse square, that means R square, is going to be equal to height square, that is Q sin theta square, plus base square. The base is going to be your P, first this force P plus this part Q cos theta plus Q cos theta whole square. I hope you can understand. This part is P, this part is Q cos theta, that is we have taken the base is equal to P plus Q cos theta. So this is going to be a Q sin theta, Q square sin square theta plus P square plus 2 PQ cos theta plus Q square cos square theta. Now what we can do from here, P square plus 2PQ cos theta plus Q square sin square theta plus Q square cos square theta. Okay, so P square plus 2PQ cos theta plus Q square sin square theta plus cos square theta. Sin square theta plus cos square theta is equal to 1. So finally the resultant is P square plus 2PQ cos theta plus Q square. Okay, so I don't have any place to write, so that is why I am removing this figure. No, I can't do this. So for that, what I can do, okay, I can write it in here. The resultant R square is going to be P square plus Q square plus 2PQ cos theta. Okay, or you can say R is going to be root over of P square plus Q square plus 2PQ cos theta. Okay, so this is going to be your resultant. Okay, so this is the magnitude of the resultant, and what we need, what else we need is what is the angle of the resultant at which it is acting with P, that is alpha. So kindly note this, and after that we are going to see. Okay, what about alpha? Alpha is, suppose we take this alpha to be your tan alpha. Tan alpha. Tan alpha is this height. This is Q sin theta divided by, we know this is P plus Q. P plus Q cos theta. Okay. So this is going to be your formula for finding the angle. Alpha is tan inverse Q sin theta by P plus Q cos theta. So this is the angle. Okay. I hope you have understood this, so I am cleaning this. Now, there is one question: what happens if the direction of Q is opposite? That means, see, this is P and this is Q, but the direction is opposite. That means now Q is this. Okay, this is the angle theta. Theta is same between P and Q. Now we cannot write this formula to be R square. R is equal to root over of P square plus Q square plus 2PQ cos theta, because this Q is acting in the opposite direction. Okay, So now we'll have to take the Q like this. See, it is like this Q. How we can do that? That is the law of transmissibility of force. That means the magnitude and the direction of Q is same, and also the line of action of this and this is same. So now we can remove this one and we can replace this one with this. Okay. So when removing from this one, see, if this is theta, this is a straight line. This is a straight line. If this is a straight line, then this is going to be 180 degree minus theta. Okay, this is the only difference, nothing else. So if this happens, then what will happen? Only our formula will get a little bit modified. So in this case, what we can do, our resultant is going to be parallel line to this and parallel line to this. Then this is the resultant. This is the resultant. Okay. See why we cannot do the result. We cannot find the resultant in the previous case, because in the previous case the P and Q were acting like this together. Now the P and Q are acting, one in this direction and one in this direction, the opposite direction. So that is why resultant is also reducing. Say the length has got reduced. Okay, previously the length was more. Length has got reduced because the forces are acting in the opposite direction, nearly opposite direction. We'll see some cases, but for now, you see this is acting in the opposite direction, so that is why resultant has got reduced. So our formula should give us the same kind of thing. See, R square should be equal to P square plus Q square plus 2PQ cos not theta. In this case, this is 180 degree minus theta. How to remember this? Say the tail of Q and tail of P should meet, not the head of Q and tail of P. It's not like that. It will be in the case of triangular law of forces, but not in parallelogram law. In parallelogram law, the tail of Q and tail of P must be meeting. Okay, the opposite will be in triangular law. See, so this is R square is equal to P square plus Q 2PQ into cos 180 degree minus theta. Okay. If this happens, cos 180 degree minus theta is minus cos theta. You remember? I don't know whether you remember this or not, but you need to remember these things. So R square is going to be P square plus Q square. Cos 180 degree minus theta is minus cos theta. Okay, so together this is going to make minus 2PQ cos theta. Okay, so this is R is going to be root over of P square plus Q square minus 2PQ cos theta. So this is your answer. Okay, so this is the case. Next is what we are going to do. We are going to see some questions that to understand the things, we need to see some questions. Okay, we need to solve some questions. So this is question number 1, Q1. Okay, the first question is telling two forces are acting on a body, and when the forces will be, the resultant will be maximum, when it will be minimum, and when it will be what will be the resultant when the forces are acting at 90 degree. I am telling you again, repeating the question. Two forces are acting. Okay, two forces are acting, P and Q, and at an angle theta is variable. Okay, when the forces, the resultant of the forces will be maximum, when the resultant of the forces will be minimum, and what will be the resultant when these two forces, when this value of theta is 90 degree. So in first case, when it will be maximum, see, we know r square is equal to p square plus q square plus 2pq cos theta. This p is constant, this q is constant, only variable is this theta, cos theta or theta. So the resultant will be maximum only when the value of this cos theta is maximum, and the value of cos theta is maximum when cos theta is equal to 0 degree. That is, in case of sin theta is maximum, in case of theta is equal to 90 degree, for cos it is 0 degree. Okay, cos 0 is 1, and 1 is the maximum value of cos. So when the value of theta is 0 degree, then only it will be maximum. The r square is equal to p square plus q square plus 2pq cos 0 degree. Okay, so cos 0 is 1. Cos 0 is going to be 1. Okay, so in that case, r square is equal to p square plus q square plus 2pq. Okay, so r is equal to overall p square plus 2pq plus q square is p plus q whole square. So r is equal to p plus q. Okay. Now from the figure also we can see that it is of course maximum when p and q is having 0 degree angle, and that resultant will be having p plus q. Okay, see, this theta is 0, then what will happen? This will be p and this will be q. So this is going to be p, this is going to be q, and they are not having any angle between them two. It means 2%, one person is p, is pushing something, q person is also pushing something. Okay, together they are working in the same direction, then the work will be done easily. So this is the maximum case of result. In this case the resultant will be maximum when the theta is equal to 0 degree. When it will be minimum, that also you know. The value of the resultant will be minimum when the cos theta will be having its least value, and the least value of cos theta is not 0, it is -1. -1 for 180 degree. See, r square is equal to p square plus q square plus 2pq cos, I am directly writing 180 degree. 180 degree, and this value is -1. -1. So in this case, r square is equal to p square plus q square minus -1 minus 2pq. So this is r square is equal to p minus q whole square. R is equal to p minus q. Okay, so easily you can understand. One person is giving some force in this direction. So this is the force P. Now the force P is acting like this. Okay, it is giving some force in this direction. Another force Q is acting in this direction. This is P and this is Q. So the resultant of these two forces will be minimum when this angle between these two is 180 degree. Okay, it means some person who is stronger, he is pushing something in this direction. Another person who is weaker, he is pushing something in this direction. But there will be some resultant. The strong person will win, but the resultant will be minimum in this case. If the two persons are acting in the same direction, then the resultant will be maximum. Okay. What will happen when the angle between these two is 90 degrees? So say r square is equal to p square plus q square plus 2pq cos 90 degree. 90 degree is cos 90 degree is 0. Cos 90 degree is 0, that means r square is equal to p square plus q square. Okay, this part is going to be 0. So r is going to be root over of p square plus q square. In case of 90 degree, the resultant is going to be p square plus q square.